So you can learn that.
That's the kind of question that I can. ¿Quiere que todos sean desgraciados?
So you can have the code, but you can't instead have an instance of it.
Well, maybe the Twitch contains
Let's get started.
Yeah. I think it starts at 8. Can't watch my discounts. But yeah, with the other social media, I have to work with that, going to
Okay, so the midterm is going to be next Wednesday. I think you've all been studying for it.
I just want to the story about
The midterm is going to be in the evening, 6:30 to 8 p.m.
garbage.
And then the best way to study for the midterm is to study the sample midterm, which is already in the lectures repository. So you can check it out. And you have the actual midterm text, you have the solutions for it, and then you have all of the projects, the actual code that you need to answer the midterm as well. Then programming assignment number 4, lab number 4, so that's kind of typical standard stuff you have to be working on. And then exercises and readings. So there's no new material that we'll cover today, or Monday or Wednesday, so we're just reviewing. So the best way to study for the midterm is to do the sample midterm, to carry out the exercises. There's a bunch of exercises online, so you should really, no excuse, you should really work through all of them. And then review the readings. Okay? So today is going to be a lecture lab. For the lecture lab, you're going to need to check out Space Invaders refactored. That's also in the lectures SVN repository. So if you have a computer, take it out, check out the project, and then I'll post a set of questions that will be answered in the lecture lab. That's the plan for today. On Monday, we're going to have the QA review. So you'll come to class and you'll ask me questions, anything you really want about the material that will appear on the midterm. And I'll try to answer them as best as I can. And then Wednesday is going to be a review. We're going to review the programming assignment. So we've essentially showed you the solution to the first one, right? And then after that, we sort of stop. So what we'll do on Wednesday is actually go through solutions to each of the programming assignments that you've had so far, including number 4, which is due on Sunday. And then finally, there's going to be an embargo on Piazza and question answering starting on Tuesday evening. So if you really have questions that you need answered, you have to ask them before Tuesday. Okay, so ask them today, ask them on Monday, send us email, go to Piazza, but Tuesday evening it's gonna shut down. Okay, great. Any questions about the schedule or the midterm or anything like that?
Where's the location?
Location will be posted. We'll let you know on Monday. This is the lecture lab. So just as before, I'm going to leave these up here, and then you can work through them on your own. And raise your hand if you want me to come over, and then I'll just come over and we can talk about your questions. Otherwise, maybe in five minutes or so, I'll start working on the first one. I'll draw it out. And every 5 minutes or so, I'll go back and try to solve each of the questions.
Yeah, I finished for like just I still want to push this. What was, do you know what that was? Well, regarding I don't know, it was like some matrix with like C squared minus phi. Oh yeah, because it's the second one was the second one was actually 3 years ago. I made him up. Oh, you made the 3? You plugged into
What's it's not good.
That's like how you. That's how you
Why would you look at it?
No, I mean, I just looked at the
Where's the last one? It's like longer. There are more readers like this. It's my type. And it is very specific. Probably her field unrelated to so it moves and it's probably she's a grad student.
How would you write that? Like that. You'll read all right.
Yeah, but abstract. So we just well, in this one, well, it's always nice to have like a student who is in the class, but you know, he's trying
One math teacher. Because the abstract class, we had to write like that. Okay, yeah. Okay, so.
You just have two different sides.
Okay, let's do the first one. A. Finish the type hierarchy for all of the classes in the following package. So if you open it up, here it is. So here's my space invaders model in this new refactored space invaders project. And I have I have 5 classes, right? Those are the ones I'm highlighting. So if you have 5 classes, that means your diagram needs to have 5 nodes in it. Right? That's just starting point. So each of those 5 needs to be in the diagram. And now, really, the question is, how do they relate to each other? Right? So let's work through this. So let me just draw all the boxes, right? So I'll say, okay, here's SI game. Yeah. Here's SI game. Here's first name. Here's Giselle. Here's Invader. The box for each. And then there's the one extra class that I'm missing, which is Sprite. The abstract. Here. So now I have to reason about the relationships between these. So Sprite doesn't extend anything, it doesn't implement anything. It's either alone or it's at the top of the hierarchy. Right? Then I look at, say, Invader. Invader extends Sprite. So that's an extends relationship. So I know that Invader is below Sprite. So I use a solid line. That's my extends relationship. Missile, same reasoning. You look at the top, you look at the definition, and it says missile extends Sprite. Same exact thing. Just connects up to this line in the hierarchy. SI game. SI game doesn't extend anything, doesn't implement anything. So what that means is that there's nothing above SI game in your hierarchy. Right? There might be stuff below it. We don't know yet. Sprite. Covered it before. Nothing above Sprite. And then tank. Tank extends Sprite. So final tank hierarchy looks like this. So SI game is just off on its own, and that's completely fine. There's just no relationship between SI game and the other classes in this package. But you have to include all of the classes in the package. Okay. So this is A. Questions about how I came up with this? Kind of relationship between all of them? So one thing that people asked is, so the Sprite class, it's abstract. So from this diagram, do I know whether Sprite is abstract or not? No way, right? So Sprite could be a concrete class. It doesn't have to be abstract. This diagram doesn't say anything about abstraction. So the diagram only captures the relationship between the types in my program. Basically says what is a subtype and what is a supertype and what is not. And that's all. So is this a class or an interface? Could it be an interface? No, why not? Right, because I can't extend an interface. I can only implement an interface. So it would be a dotted line, right? Yeah.
Does it matter where you draw the SI game? Does it have to be the same level?
Doesn't matter. It has to be somewhere in the diagram.
So if I open the type hierarchy, you will show object and then SI game and then sprite.
Right. So this is a useful thing to know. If you press F4, if you highlight on the project and then you press F4, then Eclipse will actually open the type hierarchy for you. So that's super useful. So you don't actually have to do this exercise manually if you know what to do in Eclipse. So F4 opens the type hierarchy, right? I should probably write this down. F4 in Eclipse. But you still have to interpret this type hierarchy, right? So on the exam, you're going to have to reason about subtypes and supertypes, right? So perhaps you can draw the diagram, but then can you actually tell me why it is the way that it is, right? So if you can't reconstruct the diagram on your own, then you're in trouble. Okay, so you have to know how to interpret it. So in Eclipse, your type hierarchy for the project has a bunch of stuff in it, but really you're interested in just the sprite hierarchy, which has invader, missile, and tank underneath. And then it has the SI game separate. So there's a bunch of other classes here that are irrelevant to this package. So those are the only ones that you care about are SI game and spray. So useful to know. All right, carry on. Let's do B.
Actually solve for the value of power. So like the operation thing, you had like so it goes like this. It's and so you have 3 of these, right? Another set that was like 7.
Alright, so we have this type hierarchy. So do we have abstract classes in the type hierarchy? Yes, no? Yeah, right. So sprite is an abstract class.
And you just tie.
Right? You just look at, you just open up sprite and it says at the very top, abstract class sprite. So you know it's abstract. Okay, so what functionality is defined in the abstract classes, which is common to every subclass of that abstract class. So this one's a little tricky. So you have to look at, let's say, the outline for sprite. And then here are all the methods that you have in sprite. So you have getX, you have getY, getWidth, getHeight, move, draw, and rotate. Now the question is, which of these methods are inherited by the subclass? Right, that is, which of these methods behave identically in the subclasses? Okay, that's really what the question is asking, about common functionality. So in order for me to answer this question, I have to look at each of the subclasses. So I have to look at invader, I have to look at missile, I have to look at tank. and see what happens for each of those methods. Okay, so we're going to go through each one. All right, so we have getX. Sprite is a constructor, so if you look at getX, you say, okay, what happens with getX in Invader? Does Invader have getX? Doesn't have getX. So what happens when I do Invader I equals new Invader I dot getX? What code runs? Right, so the example is I have Invader I equals new Invader. I could do the Invader is a class that I can instantiate. And then I do I dot getX. What happens? There's no getX in Invader. What happens? Is it legal? It's legal, right? So it goes up to the sprite class. It inherits that method. So if I did not override it here, that means it's going to go to sprite, the superclass, and call whatever getX does here. So that's common functionality. That's inherited. Okay, so for this answer, getX is one of those methods that's common. Well, it is common for Invader. Now I have to check it for the other ones. So open up missile. Missile doesn't have a getX. Identical behavior. If I open up tank, which is the third one, it also doesn't have a getX. So identical behavior. So that allows me to put getX and state that it's common functionality. So then I look at getY. So getY, Invader has no getY. Tank, you can just look at the list of methods that are defined here in the outline. There's no getY. And missile, also no getY. So getY is another one. Go back to sprite. All right, get width, get height. Let's do these together. So we have Invader, get width, get height. Nothing defined. Tank, get width, get height. Not defined. Missile, get width, get height. Not defined. So you add those as well. Get width, get height. And we have a couple more in sprite. We have move, we have draw, and we have handle boundary. Okay? So one thing you can note is that draw is an abstract method. So an abstract method has no implementation in the abstract class. And if you have subclasses, and those subclasses are not abstract, then they must implement this method. Right? Because in order for them to be not abstract, they have to provide implementation of all of the methods that are abstract, possibly in the supertype. So draw is not going to be one of those common methods. Because in the supertype, there is no implementation. In the subtypes of tank, missile, and invader, you'll have some implementation. I don't know what it is, but it's not going to be this. Okay? So it's not on the list. Let's look at move. So invader has a move, but the move is overridden. It behaves differently. Right? So already I know that it's not common across all of the subclasses because there's a different implementation in move within the invader. And then finally sprite the handle boundary. So invader doesn't have handle boundary, tank, no handle boundary, and missile also doesn't have handle boundary. So I add it to the list. So the answer is you have this set of methods, and all of these methods are common functionality. Any questions? Oh, you got the first?
Draw is not in the list.
Why is draw not on the list? Okay, so if you look at sprite, draw is an abstract method, right? So there's no implementation. So if I look at invader, it has a draw function. It does something. But this is different from the superclass. Right? So therefore, the superclass does not provide common functionality that is used by the subclass. Because the superclass doesn't provide any functionality for the draw. Okay? You had a question?
There is a difference or extension of the visual function. So when it's so that they won't be considered as common functions.
No. So because I changed the behavior of the function, so like move, for example, right? So invader.move reuses the supers.move, but then also does other things, right? So it's not on the list because I changed the implementation of movement. Okay, let's do C while we're at it, because this is really, they're close together. So the question for C is, can you find an example of two methods that override an inherited implementation? And for each method, does the method extend or replace the inherited implementation? So you need to find two methods that override an implementation. Well, that's pretty easy, because we just saw in Sprite we have draw. Draw is abstract, so something must override draw, because they must provide implementation. So I could say, okay, sprite.draw is overridden. Let's say missile.draw. Has to be overridden in all of them, right? So if I look at missile.draw, here's my implementation. And that implementation is completely different, because there was no implementation in the abstract class. So this one replaces the implementation. So that's my one, method number one. Then I need a second one. What's another method that's overridden in the project? Move. Okay, so I have sprite, and sprite.move does handle boundary. If I look in invader and I see its move method, I see it's overridden. And this move does some new functionality, and then it also reuses the functionality in the super. Right, so it's kind of a complex use case. It adds something extra, and then it also carries out whatever the superclass does. So I'll say invader.move overrides sprite.move and extends the implementation. And it extends it because it reuses the superclass's move method. So it sort of depends on it. And in this case, it does whatever super does, and then it also updates its X and Y in some local, meaningful way.
So if it didn't call the superclass, would you say that it replaces the implementation?
Yes. If it didn't call the superclass, it would replace the implementation. Great. All right, keep working on D and E. Sort of.
No, but you said it's not. abstract class.
Okay.
What's the point of abstract? If you just overwrite it anyway. Overwriting something is just yeah, that's I guess that's just the question.
So, and then think of an abstract class as being a combination of a concrete class and an interface. So it has features of both. Abstract methods are features of an interface because it allows me to say that every subclass must implement this method.
Geometry is not American.
You have to have that to decide. That's right.
So missile and invader, they must have a drawing.
It's more like not functionality.
Invader could just omit that. And that would be a problem.
Okay, so it's more for the coder. It's more for understanding the function. Like, in theory, you could do that. You could have that the same functionality just by having by being careful. But this just makes sure that you could be careful. I guess that's bad code. The user is
So if this, so for example, I could build a library that has Space Invader library, and then I'll say, okay, I'll have a sprite object. So if I didn't have abstract class, I wouldn't implement it, everything would break. Yeah. Right? So in some sense, we have one that the user follow. So you can also write code where you create one method. That's what I'm saying. Right? And that's really bad. So it's a similar kind of thing. It's bad in certain circumstances.
Okay, so an interface is like you have to have everything that the aspect. So let's say so you can add to an interface.
You can add more things in the subclass.
So the methods of the interface can you override those?
They're overridden. Once implemented, you have to
Okay, so yeah, okay. Okay, and are they just empty methods, or do you have to say that you need or do you put the input just like the return is parameters?
When you declare them?
Yeah, when you declare it in the interface. Do you put any parameters or no?
Yes, you do. You have to specify the complete
Okay, so
signature.
but
Which
nothing.
includes the parameters.
But I guess
No
you wouldn't have the return. So
You do have to. There with like public.
Oh yeah, that's true.
Boolean,
Yeah, okay. Yeah.
You know, get true false. But there's no body. There's no break.
So and when you override something, you need to keep the signature. So you must have about the signature. Yeah. Okay. Cool. Thanks.
Yeah.
I'd ask that question. All right.
Like this year.
And I kept this. So if you want to like stop your statement, you have to say
So Trevor's part. So you said a break.
just call it like a trade
Oh, no way. That would change the so it gives you like and you really change everything. Oh, yeah, I guess. Yeah, I like stuff about it.
Well, like, do you know It's just like
The next one. Now, question C. So the question is, you've been asked to extend your game, and now you want to add two kinds of missiles. You have the skinny missiles, and then you have the wide missiles. And so you'll press different keystrokes to fire different ones, right? So this keystroke stuff, just ignore it for now, right? That's not relevant. The question is, how would you change your type hierarchy? And the question may be, why would you change it? You know, would you change it to get this implementation to work? All right, so here's the type hierarchy from A. Partial type hierarchy. Okay. So if I'm adding two kinds of missiles, what could I do to make that implementation work? Look at it.
Add two subtypes or subclasses.
That's right. I could take missile, and then I could create two subclasses. Right? And one of those will be the skinny missile, and then the second one will be the wide missile. So that's one implementation strategy. I could say, hey, actually, I'm going to make this a little deeper, and say that this is going to be a skinny missile. This one a wide missile. Right, so this is one solution. This is one way of doing it. What are some other ways of doing this? So when I'm doing this, I'm adding new notions to my class. Sorry, to my language, right? So now we can talk about different kinds of missiles. That makes the language more expressive, but it also means that I have more vocabulary. Right, so if I do this, then skinny missile should better behave kind of differently from wide missile. Right, because I'm adding two new classes. So I don't want them to be empty, right? They probably need to have difference in behaviors for this to make sense. So this is reasonable if somehow they differ fundamentally. But if they don't differ, then something you could do is actually just change the implementation of missile. So if you look at this class, internally it has a single size, right? It has a single size and one color. So I could add a new variable, something like private boolean is wide. And then I could actually keep track of whether the missile is wide or skinny within the instance of the missile. So I could add, for example, when I create a new missile, I have to tell you, what kind is it going to be? So I'll require a new argument, boolean is wide. And then within the constructor, I'm actually going to set this dot is wide equals is wide. Right, so I'm differentiating between the two missiles within the missile class itself. I'm not creating new types, because perhaps it's just kind of an implementation level detail. Right? Perhaps they don't really behave all that different. Right? So maybe it's just one boolean, and this is a much easier solution. I don't have to change my code a lot. Okay, so there's a couple of different answers for this question. Yeah, you would do the implementation change if the missiles don't really behave very differently. If all that's different about them is their size, then who cares, right? I can just have a missile represent both. If perhaps one you know, every time I fire a missile, the skinny one, you know, travels faster, for example. Then I'm actually changing something behavioral about the missile. Then it would make sense to do the deeper type hierarchy. Okay. What about E? So it's referring back to D, and it says, okay, so if you decided to add classes in D, so now we have assumed that our solution was this one, where I have two kinds of missiles. So now the question is, would I need to override any methods in those classes? List any methods that you would override, and why. So what would you need to change if you had a deeper type hierarchy? I assume that I removed this implementation solution. And so I decided to subclass missile. So I'm going to have two subclasses. So what would I need to change in those subclasses? So really there's like three things, right? There's the constructor, there's the draw method, and there's move. Can I keep all of them? Do I have to change all of them? What do you think? Zach?
I'd change all of them, except for the constructor, but you'd have to draw definitely different missiles because they'd look different.
Yeah,
And
I mean,
move.
one is skinny and one is wide, right?
And I assume they'd move at different speeds too, otherwise there'd be no point of difference. So.
Yeah, so if you're going to really subclass them, so you might as well create new implementations for both of those methods and override them.
Could you make the missile class abstract?
The missile class, you could.
And then why only the constructor?
So when would you make a missile class abstract? What do you think?
Because you're not interested in differentiating like missiles. You have skinny and wide.
Right, so maybe it doesn't make sense to like instantiate a missile. There's only two varieties. Just like it doesn't make sense to, like, when you see a mushroom, it's not, you know, mushroom, the platonic mushroom. It's some specific kind of mushroom, right? So it makes no sense to see an actual mushroom, like the way we would define it in a textbook. So maybe a missile, when it exists, it only exists in two forms, as a skinny missile or a wide missile. So then you would make it abstract. But it's not a requirement. It kind of depends on what you want in the game. Perhaps you still want the regular missiles that have this standard size. So maybe you would call it like medium-sized missile. So it depends, yeah.
Even if they had different speeds, would you really need to override move?
If they had different speeds, would you need to override move?
You could just change the value of dy. It
Yeah.
would stay the same.
So that's a good question. Would you need to override move? So missile.move, here's the implementation. And what does it do? Well, it changes my y-coordinate of my missile, and then it does whatever the superclass does. Right? The key question here really is this dy field. So we didn't actually cover, so all of these guys are capitalized because they're static final. So we didn't talk about static fields, static methods, or final keyword. But what final means is that you can't change its value. So final freezes the value of size x and size y and dy. So what that means is that if you subclass it, you can't change dy. Right? So if you wanted to have different behavior, you would need to override it. But that's assuming that you make no changes to missile. Right? Because you could make dy non-final, and then you can make changes to it. So yeah, so it would depend on how you would change missile. And I think in the question, the assumption is that you don't change missile. Right? What would you override? Keeping missile intact. So you would have to override. Okay, great. Work on these on your own. We'll post the solutions to these, so you'll have them available.
Well, no, today I was Maybe, but like, yeah, actually, I don't know. That wouldn't really make any sense. Why would my knees hurt from not swimming? Maybe Chris and Claudia would.